You lost your
No, I can see it. It's
I need to make sure the
So now we have to do without PowerPoint.
good. I will introduce myself. My name is Daniel. I will talk quickly. I'll talk quickly about material analysis of the British road network. This is what I've done during my time as a two-short fellow here at Cambridge. Where does it all started from? Nowadays, man-made materials exceed actually the biomass on our planet. So we actually have more concrete, more gravel, and also asphalt somewhere in the graphic. Then we actually have trees or living animals here on this planet. And roads actually contribute to this whole material system quite a lot, with roughly 5%. But it's still 4.4 gigatons per year. And roads also contributed for roughly like 1% to the global greenhouse gas emissions, which we all need to reduce by 2050, some countries 2035. So what I have done is a retrospective analysis of the road network. This is actually a picture of the British road network, where black ones are main roads and red ones are minor roads. So technically it really structures spans across the whole isle, a little bit less in Scotland. My system boundary was 20 years, and geographic region Great Britain. I used two different approaches. I used the top-down approach and the bottom-up approach, which I come to now. Those are the equations I used. The top-down approach mainly focuses on statistics collected in different government institutes or in private organizations, where I calculated the stock change by just subtracting inflow from outflow, whereas the bottom-up approach goes into the direction of like having a material inventory, then calculating the metric objects times your material inventory, and then you can decide how much goes in and out by just comparing different years. How does it look like now on our road network? As we showed says already, mainly asphalt is used, roughly around 99%, then a little bit of concrete, other paving materials, and everything of this sits on top of granular materials, sand, gravel, compacted nicely. And then natural earth, which is not really considered in this case any further. I need to do some harmonization before I could start, so I looked at the different road network data that was provided by different governments. We can see the UK government kind of was a little bit overestimating or underestimating what then was published by the Welsh and the Scottish government, so I did a little bit of harmonization to come out with a better network, also data gaps in years or changes of methodology, so I flattened this all out to get one smooth curve in the end to calculate the road stock. So how does those methods all compare? Those are the results of the bottom-up. The top-down analysis, where I compared different data sets. One was from the European Asphalt Pavement Association, and one was from the Mineral Product Association. They both use kind of the same data set, which is based on the British Geological Survey. Here we can see they all come to the same values, more or less plus minus, with a certain uncertainty in those systems. Now comparing both approaches, the top-down and the bottom-up approach, we can see for the asphalt it matches quite closely, with in the beginning a little bit of an error due to I had to start at some point, so my material stock needed to be developed, and it catches up quite well. Whereas when we look then at how much asphalt is actually then recycled, the top-down approach, or not recycled, comes out of the system. And the top-down approach actually underestimates it, whereas the bottom-up approach showed there might be much more material coming out. Here a big difference is the top-down approach relies on statistical data, and asphalt is often less reported of how much actually get out. There's a little bit of reports of how much is recycled, but it's often underestimated of how much actually is there and how much is actually in use. The same goes for granular materials. Here the huge difference between the bottom-up and the top-down approach is in the bottom-up approach, as I said, I multiplied how thick actually those base layers are times the length, which might here a little bit underestimates how much material actually was used because of different thicknesses over the whole road network length. So let's focus on one picture in 1 year in 2019. Let's focus first on how big the stock is. We can see granular materials dominate our stock at the moment with roughly 56%, followed by asphalt, which is natural, seeing that the road network mainly consists of asphalt roads. Then let's see on the import. Nearly 95% of all materials comes from minerals. It's mainly crushed rocks, sand and gravel, rock chipping, and of course the minerals in recycled asphalt. We have a little bit less than of other materials like bitumen, and this whole thing is mixed, and then we get roughly 54% of asphalt coming into our system, maintaining our 43% asphalt in our stock. So we can see already, due to the high use of asphalt, especially in surface layers, that we need to continuously maintain our system. This maintenance is especially reflected in that roughly, don't do something wrong, 49% of all materials are actually used for maintenance purposes. So actually the new construction of new roads add only up to roughly 8% of those material flows. Then when we look at the right side, the outflows, since we put a lot of asphalt in, a lot of asphalt comes out at the end due to our maintenance efforts, whereas we can see recycling is less done. A lot of asphalt is actually downcycled for backfilling, for lower layers, or just sits somewhere at the moment without being further used. We also have some flows in the environment, which is quite low. This comes from abrasion, raveling, materials that is lost during the construction process. And a little bit goes to landfill and incineration, which should phase out in the future. So how does this now go into with our greenhouse gas emissions? Asphalt is a very energy intensive product, also responsible for a lot of emissions. And since we use it quite a lot, it is the main driver of emissions in road constructions. Other materials add nearly to nothing, especially stones are often recycled, so the emissions are quite lower. Concrete is emission intensive, but since this less used in the road network, it was a minor share. Granular materials, we use it still quite a bit, but since they have less emissions, since they're just excavated and put into the road, their emission contributions is also quite lower. So what can we do for the future? I mapped it kind of out, trying to focus here on asphalt, unbound materials and construction phase. Yeah, recycling helps, it reduces our emissions. We can also kind of lower the production temperature. On average, we are here by 20% roughly. We can use sustainable fuels, which gives us roughly about 30% emission reductions, but there's no single solution so far. So we have to all work together, different measures actually, to really achieve net zero. And maybe also here in road constructions, we might have now the chance actually to change completely how we build roads. We heard geopolymers might be a more environmental friendly way to at least reduce some emissions, maybe change completely our binder system, go away from the fossil fuel binders, more to sustainable, renewable binders in the future, but that will be to be determined. So, thank you very much.